Okay, so guys, today our topic is mean value theory. So inside mean value theory, we have Rolle's theory, Lagrange theory, and then we will identify increasing and decreasing interval, and then we will learn L'Hopital's rule. Okay. So firstly, let's talk about Rolle's theory. Okay. So if we have a function f of x and we have a interval a and b is given, okay, we have a given interval a comma b, so it can be 1 comma 2, 1 comma 3, so anything, and this is a closed interval. So if our function is continuous in this closed interval, and if this function is differentiable at a comma b at this open interval, so you can see the sign here, first bracket, and this is third bracket. So this is an open interval, and this is a closed interval. So if our function is continuous at this closed interval, and if our function is differentiable at this open interval, and also the third condition is f of a must be equal to f of b. Okay, that means suppose 1 equal to a and 3 is equal to b. So we have to these two functions will be equal. Yes, Rajiv, I can hear you. Yes, Rajiv, I can hear you.
How can I understand it is differentiable and continuous?
Okay. So I will discuss
Maybe.
about later. Okay, just a moment.
Okay.
So this is our general theory of Rolle's theory. Okay. So we have three conditions. Number one, this is a function f of x, and this function is continuous at this closed interval. So this a and b can any number. Number two is this function is differentiable at this open interval a comma b, and f of a and f of b will be equal. For example, I have given a interval 1 comma 3. So this is a closed interval. Here 1 is equal to a and 3 is equal to b. Okay. And then the theory is f of a, the derivative of this function. That means, for example, here is a and here is b. So there will be another point inside of these 2 points. There will be another point here. You can see here. So there will be another point where the derivative will be 0, because we know that we know that its slope is 0 degree. You can see the blue line here. The slope of this blue line is 0, because it's tan 0 degree, and we already know that tan 0 is equal to 0. Okay. Or you can say any horizontal line, its slope is 0. So this is the Rolle's theory. We have to test these three things. Firstly, this function have to be continuous at a comma b, and this function have to be differentiable at a comma b, and f of a should be equal to f of b. Then we can find a point inside of a and b. So see here, a and b, and this c is in between a and b. So we will find a point inside of a and b, and its and derivative of this point. Okay. It will be 0. Or you can say that in this point C, our tangent value is 0. Okay, guys, can you understand?
Yeah.
Okay, I'll give you a more real life example. Okay, and for the for the second theory, that is Lagrange theory. So we have a function here, this red color, this is a function. And if so this blue line, the bigger one, it is a tangent line, and the smaller one, this is sorry, this is second line, this is second line, okay. And you all, you know that second line, they intercept 2 point, they intercept 2 point, like you can see on point, 2 point, but tangent line only intercept with 1 point. So for example, this this small blue line, this is tangent line. So the theory is M is equal to tan C. The theory is like before. So we have to see number 1 and number 2. You can see A and B. This for this function f of x, this function is continuous. This function have to be continuous at a comma b, at this closed interval, and also this function is differentiable at a comma b, this open interval. Then we can say that our tangent line and our second line, they will be parallel. That means we have a point A here. This is our A point, and this is our B point. And the rule is there will be another point inside of this A and B. So you can see here C point. This C point is in between A and B. So this point, if we draw a tangent line from this point, so this line will be parallel to this second line, okay? Or you can say like this way. F derivative C is equal to f of B minus f of A by B minus A. So f of B minus f of A, this is our second line. Okay, this line, this bigger one, this blue color line. And f derivative C, this is this smaller blue line, okay? And the theory is their slope will be same. M of tangent line will be equal to M of second line. You can see they are parallel. So parallel means their slope is equal. Guys, can you understand or not? Maybe it is the first.
Yeah, I can understand.
Okay. So little by little, it will become more easier, okay? And I just revised today, okay? So that's why. So we have learned Rolle's theory and Lagrange theory. So let me tell you again, just to make it simple. So if we have a function f of x, and we have also interval like a comma b. So for example, this was a function, but we are only considering this red portion, okay? So it can be like 1,5, okay? Like this way. So here on is our A and 5 is our B, A and B. So if this function is continuous at A comma B, and if this function is differentiable at A comma B, and if f of A is equal to f of B, then we will find another point C that is between A and B. Okay, you can see here C, this C is between A and B. And for this C, the derivative of C will be 0. Or simply the tangent line at this point C, it will be 0. And the second theory, that is Lagrange theory. So it is first we have to you have to see these two. You must prove these two things. Like this function have to be continuous at a comma b, and this function have to be differentiable at a comma b. Then you can say that this tangent line, for example, this is on line, this is a comma b, this is a, and this is b. So we will find another point c that is between a and b. You can see here, and their slope will be same. M tan is equal to m sec. Okay. So we can write down this way. This f dash c, this is tangent line. This is this blue tangent line, and this part f of b minus f of a by b minus a. This one is this part. So this two line is parallel, and their tangent value is their slope is same. So this line is called sec line or second line, and this line is called tangent line. And tangent line touches a parabola or a function only on point. See here, on point. And second line touches 2 point. On point is here, and another point is here. So guys, can you understand?
Yes, Laoshi.
Laoshi. No, I'm not Laoshi. I'm the Pangyo. Abujia Laoshi. Abushi Laoshi.
No. Lishi what, Laoshi?
Okay, Topu, do you understand?
Yes, bro.
Dakira, do you understand?
Yeah, a little bit.
Okay, so it will be more clear little by little, okay?
Okay.
So for example, let's look at our homework. So here we have, so I don't know the answer of number 1. So Alex sent me some example, but I didn't have much time to review. So I will take another class for number 1, okay? And for number 2, we have a function. This is x cube plus 3x square minus 9x plus 14.
Well, I can understand how about number 1.
Yeah, I also don't understand, so I have to review another solution. Okay, Alexander Sinok just send me that. So
what can I do now?
No problem. I will research.
You can word. You have to word
Alex.
for that.
I'll tell
No.
you. I'll tell you.
Okay.
I had.
But maybe today's the last to send homework.
Yeah, I also didn't send the answer. You can see here. I didn't send the number on. I didn't send number on answer. I just cut it. I just canceled it. So we have a function f of x is equal to yeah, x cube plus 3x square minus 9x plus 14. So we have to find all the critical points of this function. So let's have a look at the graph. So this function is like this way, okay? This function look like this, like this way. So you can see this point here, this point here, and this point here. These 2 points are special, right? Because this function was going downwards, like this way, and this function was going upward. So this 2 point is special. So we tell it like global. It is our extreme value. Okay. One is here and another is here. We also tell it like critical point. So to find the critical, our question was, we have to find all the critical points of f of x. So to find the critical point, we just need to find the derivative of this function. So derivative of x cube minus 3x square minus 9x plus 14. So it will be, you just take this power down here, and you just subtract minus, you just subtract 1, okay, in the power. So it will make 3x to the power 3 minus 1, or this is 3x square. Again, the derivative of 3x square, it will be, you pull this power down here. So 3 multiplied 2 is 6, and you decrease the power of on, okay, you decrease, or you just subtract minus 1 here, like 2 minus 1. So it will be 6x. 3 multiplied 2 is 6, and 2 minus 1 is 1, so 6x. And derivative of 9x is equal to 9, and derivative of constant equal to 0. So now, so we know that critical points can be found at 4 point. Number 1 is derivative of x equal to 0. Number 2 is derivative of x is undefined. Guys, do you remember?
Yes, yes.
Yeah. Number 3 is in point. In the in point value. Okay. Where is that note? Advanced math 7. So here we are using our first, we are taking this first thing.
Rules.
This is f of x, derivative of x will be 0. So we already got our derivative, so this will be 0. And now we just common 3, or we just divide using 3. So if we or you can say that we factorize 3 here. We just take 3 out, then we get x square minus 2x minus 3 is equal to 0. Then take this 3 here, so it will be 0 by 3, or you can just divide by 3, okay. So divide 3 here and also here. So it will make x square minus 2x minus 3 equals 0. And then you have to break this middle term, or we just say middle term break. So minus 2x, it will be minus 3x plus x. So again, common x, take x common, and you get x minus 3, and take plus 1 common, so you get x minus 3. So our final result is x minus 3 into x plus 1. So we know that if these two are multiplied, we know that if a and b is equal to 0, so a will be also 0, and b will be also 0, right? So x minus 3 equals 0, or x plus 1 equals 0. So x equal to 3 and x equal to minus 1. And now we have to find, so this is our value of x. So this 2 point, in this 2 point, we can find some critical, we can find our critical value, okay? So now we have to
why it is critical?
We have to substitute 3 here, here in our main function, okay? Here in our main function, this function. We have to substitute this 3 and this minus 1 in our main function, because this 3 and minus 2, this 2 point, this 2 point is our critical point. Okay, guys? This 2 point is our critical point. So we have to substitute this 2 point here in our main function. Okay. So if you if you substitute 3 here, so it will be 3 cube minus 9 into 3 square minus 9 into 3 plus 14. So altogether this is 27 minus 63. No, 81. Minus 21, 27 plus 4 plus 14. So altogether this will make maybe 0. No, this will make this will make 19. This will make minus 13. Okay, let me calculate it. So 14 and 27. 1, 4. No, I have done something wrong here. Maybe 14.
Use the calculator.
No, I don't need the calculator. Okay, let me see where I put it the value. 3, 27 and minus 9. Oh, I wrote this wrong. This 9 is not correct. This will be 3, okay? You see here 3x squared. So I wrote this wrong here. So it will be 27 minus 27, then minus 27, then plus 14, right? Okay, this part is here. So 27 cancel, and 27 minus 27 plus 14 will be 3 and 1, 13, okay, minus 13. So you see, if we substitute our f of 3, f derivative 3, f of 3. So f of 3 is minus 13, okay?
Minus 13.
Yeah. So our point is 3, minus 13. 3, minus 13. So now we have to put this point in our graph. So it will be somewhere around here, 3, minus 13. You see here, minus 5, minus 10, minus 13, and 3, 1, 2, 3, okay? So this is our point, 3, minus 13. So this is on critical point. And you just, again, the same thing. You just put minus on here. You just substitute minus on here. And you will get 19, okay? You will get the result 19. So this is also another critical point. And if you look, 19 and minus 13, minus 1. So what was our question? We have to find the critical points. So these two things are our critical point, like minus 119 and minus 119 and 3, 13, okay? 3, minus 13. So this is the solution for number 1 question. And so guys, do you understand?
Yes.
Okay, Rajiv, Zakira?
Okay.
Yes. Okay.
Okay, thank you. So next one we have to identify the interval on which function is g and down. That means up and down, okay? So where our function is increasing and where our function is decreasing. So for this, we have to draw some table. So we already know our value. Our critical point is 3 and minus 1, right? We already found our critical point is 3 and minus 1. Okay, so you can see here. Now we just take a line, a straight line, and we mark 1, minus 1 here. So this is 0 and this is 3. So we get 3 person. One person is here, another person is here, and we have another person in the middle. So we have to input this these things, right? Like this one, and also this -1, also -1, 3, also this 3, and also this 3, plus infinity. So we have to take all this interval here. See here? Okay. So now you have to find the derivative value of these intervals. Like this is our derivative. We already calculated in our previous math, right? Here. So we don't need to calculate this derivative again. We can use this. Now, if you think like a number, if you take any number between this, okay? So for example, -infinity to -1. So we can take -2. We can take -3, right? We cannot take 2, or we cannot take 5, because our interval is -infinity to -1. So we can take any value inside of -infinity to -1. So for example, I took here -2. So if derivative -2 will be 15. So you can calculate here 3 into -2 square minus.
Omar, can you repeat from the beginning?
From number 2.
From the beginning, intervals. From intervals.
From the beginning means
As a fish. As a fish.
from this example, number 1 or number 2?
No, ওই কোশ্চেনের প্রথম থেকে।
Oh, this number 1. Find all the critical points.
Oh no, number 2, number 2.
Oh, number 2. Okay. So I got it. So firstly, now we have to find. We have to identify the interval on which our function is increasing and decreasing. Okay. So for this, we already found the derivative. This is x cubed minus 3x square. So derivative is 3x square minus 6x minus 9. Okay. So we don't need to calculate the derivative again, because we already did in the previous math, number 1. Okay.
Okay.
So this is our derivative value, or f derivative x. And now we have to take those critical points. Like we already know that our critical point is 3 and -1. Okay, our critical point is 3 and -1.
Okay.
So we take a straight line here, and this is our -1, and this is our 3. So these two point will divide the function, divide it like 3 portion. We have -infinity to -1, and we also have this -1, and then -1 to 3, and then we have 3, and then 3, plus infinity. So we have
How
to
can you get 3 portion, brother?
Okay, so we already know that our critical point is -1 and 3.
Yes.
So if you just make a line here, -1, and if you make a line here, 3, so it will make 1 portion, 2, and 3 portion. Okay. So we have to test all these 3 portion, where our function is increasing and where our function is decreasing.
We got -infinity, comma -1.
Oh, okay. So
And then
you
like that.
see our function was coming from far away, right?
Yes.
So that's why we take from -infinity to 1, -1. So x equal to -1 means here. So if you look at the graph, here -infinity to -1. This means this portion, this part of the graph. Okay. And
Okay.
here
Okay.
3, plus infinity means this part of the graph. Okay.
Okay.
Here -1, 3 means this part. So like this way, we just divide our function in like this types of 1, 2, 3, 4, 5, these 5 intervals. Minus infinity to minus 1, minus 1, or minus 1, 3, 3, and 3 to plus infinity. And now we have to find the derivative value. Like here we have minus infinity to minus 1. So you can take any value in between minus infinity to minus 1. You can take minus 2, you can take minus 3, okay? Or you can also take minus 100, doesn't matter. So for example, I took minus 2, minus 2. So it will be, so we just substitute this minus 2 here. Okay. So it will make 3 into minus 2 square, 3 into minus 2 square, minus 6 into minus 2, minus 9. So this is 12 plus 12, 12 plus 12 minus 9. So 24 minus 9. So it will be 13. Oh, sorry, 15, okay. So f of derivative of that means derivative f of minus 2 is equal to 15. And now now we take minus 1. So if you take minus 1 here, it will be 3 into minus 1 and minus 6 into minus 1 and minus 9. So altogether,
why we have to take negative one?
you can see here our point is negative 1. That's why we take negative 1. If
We
our
have to
point
take
was
negative
like
one,
3,
okay.
if our point is 3, we take 3. If our point is minus 1, 3, so we take any point in between minus 1, 3, because this is a closed, this is a open interval. So we cannot take 3, okay? We cannot take 3, we cannot take minus 1. But we can take some number between minus 1, 3, like you can take 1, 5, okay? You can take 2.999, okay? Any number between minus 1, 3. So for example, I took here 2. So it